question to see if you know your stuff. Let's think in terms of a reaction here. I'm gonna make up a reaction here. Hey, this is gonna be acids and bases. Why not? H2SO4 plus 2NaOH is going to give me, the H is the acid, it's going to bond with the OH, and we're going to get 2 H2Os and 1 Na2SO4. Okay? All right. The important thing is there's a ratio here. Okay? There's 1 to 2 to 2 to 1. All right. The first thing is the reactant for which there is the least amount in. The limiting reactant is the reactant for which there is the least amount in grams. Well, you know, it's not really about the grams, it's about the moles. It's the number of moles that runs out first. Because, you know, you never know if 0.1 grams of this and 0.2 grams of this, if this is lighter per mole, then you're going to have a lot more of those. If this is lighter, then you have more of these. So the grams, you can't really compare. You have to go to the moles. So it's as far as the mole ratio. So that's not it. Well, here's the real answer. The answer is the limiting reactant. Remember, we find it's the one that gives you the least number of moles of product. Moles or the mass of product. Okay? So the limiting reactant is all about the which one gives the least number of moles or mass of product. That is it. So let's see if it works. Okay, masses aren't going to work because this is the reaction in which there is the least amount in grams. Nope. Is the reactant for which has the lowest coefficient in a balanced equation. Sometimes the lower coefficient is going to give that to you, but not always. Depending on how much you have. You could have less moles of this or less moles of this. You know what I mean? So this is the less number of moles. Could be the limiting reactant. But if I have 1,000 kilograms of this and 1 kilogram of this, then you know that it's going to be, this is the limiting reactant. Right? So it's not always true. A good way to do this is try to prove yourself wrong. Is the reactant for which there is the most amount in grams? Well, no, then it's not going to be the one that runs out first. But could it be? Maybe, because of the moles. So grams really doesn't help you. Is the reactant for which there is the fewest number of moles? Sounds pretty good. But what happens if I have something like a 1 to 2 ratio here? What if I have 1 mole of this, and let's call this 0.75 moles of NaOH. Actually, let's do this. 1 mole of NaOH. Okay? So look, they have the same number of moles, right? So you think, oh, no, well, there's no limiting reactant. But this one here, since we're talking about H2O, for every 1 mole of NaOH, you're going to create 2 moles. I'm sorry, it's a 2 to 2 ratio, so I'll give you 1 mole of H2O. But for every 1 mole of this, you're going to create, it's a 1 to 2 ratio, so you're going to create 0.5 moles of this. So this one produces less product with the same amount of moles. So this doesn't really help. If this says, if the reactant for which there is the fewest number of moles of product, then that would be correct. But it doesn't. So we'll cross it off. So the only answer left is E, which in Japanese means good. いいね.